Hi everyone, my name is Mr. David and welcome to today's episode of Omni Education SAT Edition. Today we're going to talk about the qualitative evidence questions, in other words, charts and graphs. These usually appear in the middle of each reading and writing section. One or two charts, graphs, or tables. So you'll be given the chart or the graph or the table and then a paragraph underneath which describes the topic. Usually the paragraph will end with a claim. The question might then ask you what evidence will support or weaken the claim, or it might ask you to fill in missing information in the claim itself. As always, we can break down the process into 3 steps. Step 1. Quickly skim over the graph or table or chart, but don't worry about looking at the data yet. Read the paragraph and identify the claim. As I mentioned, it is usually found near the end of the paragraph. Then try to summarize the claim in your own words. Step 2. Note if the question asks you for a statement that supports or weakens the claim. Take another look at the claim and then go through the answer choices, checking off those that could support the claim, or weaken it, depending on the question, and crossing out those that do not support the claim, or weaken it, depending on the question. Step 3. Cross-check the answer choices you have checked off with the data in the graph. The information has to match. You should be left with one answer that supports the claim, or weakens it, depending on the question, and that contains correct data matching the graphic. Okay, let's try one together. We'll start with the graph question. You can find this question in the comments section below. It is taken from the College Board Digital Test number 10. Step 1. If we quickly skim the graph, we can see it presents a double bar graph about spray and spin coating. Then we read the paragraph and look for the claim. Watch for claim verbs like argues, concluded, asserts, etc. Here we can find it at the end of the paragraph. The team concluded that spray coating holds promise for improving the power conversion efficacy of ETLs in perovskite solar cells. Let's try to summarize it more simply. Spray coating might improve power conversion in the solar cells. But improve from what? Note that the paragraph says that spin coating is often used, but this leads to ETLs that are inefficient at converting power. So, if you revise our summary, spray coating can improve power conversion efficiency in solar cells compared to spin coating. Step 2. Examine the question. Which choice best describes data from the graph that support Taylor and his colleagues' assertion? Now, we go through the answer choices to look for those that support the claim that spray coating might improve power conversion efficiency in solar cells over spin coating. A. Both the ETL applied through spin coating and the ETL applied through spray coating showed a power conversion efficiency greater than 10% at their lowest performing thickness. This doesn't show any improvement in the spray coating, so strike it out. B. The lowest performing ETL applied through spray coating had a higher power conversion efficiency than the highest performing ETL applied through spin coating. Okay. This might be a possibility as it states that spray coating had a higher power conversion efficiency than spin coating. Mark it with a check. C. The highest performing ETL applied through spray coating showed a power conversion efficiency of approximately 13%, while the highest performing ETL applied through spin coating showed a power conversion efficiency of approximately 11%. This one could also be a possibility as the spray coating power conversion efficiency 13%, is higher than the spin coating power efficiency, 11%. Mark it with a check. D. There was a substantial difference in power conversion efficiency between the lowest and highest performing ETLs applied through spray coating. This one only talks about spray coating, so it doesn't support the claim that spray coating is more efficient than spin coating. Cross it out. Step 3. We have narrowed down the possibilities to answer choices B and C. Now let's test each one against the data. B. The lowest performing ETL applied through spray coating had a higher power conversion efficiency than the highest performing ETL applied through spin coating. The lowest performing ETL with spray coating, the light gray graph, is 15% power conversion efficiency, while the highest performing ETL with spin coating is 13%. So choice B accurately describes the data. This could be the answer, but we will check answer choice C also, just in case. The highest performing ETL applied through spray coating showed a power conversion efficiency of approximately 13%, while the highest performing ETL applied through spin coating showed a power conversion efficiency of approximately 11%. If you look at the graph, the highest performing ETL with spray coating has an efficiency of 17%, while the highest performing spin coating is 13%. So, answer choice C does not match the data, so we can cross it out. Therefore, we are left with B. All right, your turn. These questions are also available in the comments section below. Step 1. Skim over the chart. Pause the video and note the key information. Okay, the title tells us is about the number and origin of clamshell tools found at different levels below the surface in Neanderthal caves. We have 3 columns. Depth of tools found below surface in cave, meters, clamshells that Neanderthals collected from the beach, and clamshells that Neanderthals harvested from the seafloor. Step 2. Examine the question. Pause the video and see if you can find it. Okay, however, the team also concluded that those tools were more likely challenging to obtain, noting that blank. Which choice most effectively uses data from the tables to support the research team's conclusion? Step 3. Check the answer choices against the data. We need to find the choice that shows the seafloor clamshells were more difficult to obtain while also matching the data in the table. Pause the video and go through the answer choices to see which ones match. Before we go through testing each one, let's eyeball the chart. We can see a general trend that clamshells in both categories are highest in the shallowest depths, 3 to 4 meters, then drop to single digits or even 0 for the seafloor. The one oddball number is a sudden jump of 18 clamshells collected from the lowest depth of tools, 5 to 6 meters. Okay, A. At each depth below the surface of the cave, the difference in the number of tools of each type suggests that shells were easier to collect from the beach than to harvest from the seafloor. This choice is supported by the chart, as the number of clamshells from the beach are consistently higher for each depth of tools than the clamshells from the seafloor. Check as a maybe. B. The highest number of tools were at a depth of 3 to 4 meters below the surface, which suggests that the Neanderthal population at the site was highest during that related period of time. This does not compare the seafloor clamshells being more difficult to obtain than the beach clamshells. Cross it out. C. At each depth below the surface in the cave, the difference in the number of tools of each type suggests that Neanderthals preferred to use clamshells from the beach because of their durability. As we discussed, the chart shows that the Neanderthals consistently use more clamshells from the beach than the seafloor. But again, there's nothing here about the seafloor clamshells being harder to obtain. Cross it out. D. The higher number of tools at depths of 5 to 6 meters below the surface of the cave than at depths of 4 to 5 meters below the surface suggests that the size of clam populations changed over time. This does match the table. The number of tools increases at 5 to 6 meters, but as with B and C, this doesn't compare the beach and seafloor clamshells or explain why the seafloor clamshells were harder to obtain. So, that leaves us with A as the only possible answer. The graphs and charts questions can be some of the more challenging SAT reading and writing ones, but as you can see, if you're careful and systematic about it, you can solve them quickly and effectively. Thanks for watching, and let me know your comments and any other SAT or other English-related topics you want me to cover in future videos. See you next time.